Hey YouTube, so today I wanted to show how to calculate internal resistance in a cell. A lot of people will just use the ESR function on their charger, and ESR basically passes an AC current through the cell to try and work out the internal resistance. And it's not very accurate. If you want a really accurate value, you have to use this formula here. So internal resistance is delta V over delta I. So delta means the difference. So this requires you to take two different measurements of both voltage and the current. So for that, you're going to need two multimeters. One is going to measure voltage, the other is going to measure current. And I've got this little setup here. I've got a 1224 DC element. I've got my voltage, one connection here which goes to there, and this is the other one there, so that's the voltage one going to there. I've also got the current measurement circuit, so that goes down into this meter, and when I connect here I'm going to have current flowing through the element. I can also swing over to this post here, and that will get just one, because there are two different elements here, so that will get just one element, whereas this connection is two elements in series. So this will be low current, this will be high current. Some really good chargers will misuse this formula basically. Instead of having delta I, they will just use I. So what they'll do is they'll take the resting voltage and then they'll pass current once and they'll measure the voltage again. So they are getting delta V, but they're not getting delta I, they're just getting one current measurement. So that's going to get close, but it's not going to be accurate, because the resting voltage in most batteries means nothing. So you really need to take two different current measurements in order to be accurate. Okay, so let's connect this up and we'll see what readings we get. So we've got 1.62 and 3.363. 1.62, 3.363. Alright, now for the second test, we're going to connect to the other one. And we get 2.81 and 3.36. So when we calculate, we just deduct one from the other. We get 0.003 volts, and for the current we deduct one from the other, we get 1.19 amps. So going back to our formula, delta V over delta I, so we end up doing 0.003 over 1.19, and that gives us 0.00252 ohms, which is 2.52 milliohms. Alright, so now I'm going to show you what happens if you use delta V over I. So our resting voltage is 3.372, and our first set of readings was 3.362 and 1.62 amps. So if we deduct our standing voltage from our first current voltage, we get 0.01 volts. Now if we plug that into our formula, 0.01 volts over 1.62 amps that we got in our first reading, we end up with 6.17 milliohms. Very, very different to the 2.52 milliohms. So you can see how using delta V over I is very inaccurate. And ESR would probably be even less accurate. So if you really want to know your internal resistance, you must use delta V over delta I.